going to do a video on grinding a 3/16 inch pin, hanging it out quite a long way using the Radiac 100 grit wheel, show the difference in the wheel selection. But we got this in, we bought it off eBay, and we thought we'd do a quick video on this first. And what this is it's a Tapmatic, it's a 50X, and it's an automatic tapping head. And the capacity on this one is from M3 to M12, or number 6 to a 1/2 inch tap. And what it is, it's pretty much like an automatic transmission. When you're power tapping and you're working on the mill, you always turn in your power on forward and reverse as you hit the bottom. You're tightening your tap up in your chuck, and if you power tap right, you'd want to tighten it just enough in the chuck and get a feel for it, so that if it binds up or it hits a bottom on a blind hole, that it will just spin in the chuck rather than break. But sometimes that's kind of hard, especially with smaller taps. And anybody that has done a lot of power tapping, you'll know that breaking taps, if you're not careful, can happen very easy. Well, if you get one of these tapping heads like this, it takes a lot of the hassles that you have with the power tapping out. It has an automatic transmission, so it can go forward and reverse. When it hits the bottom of the hole, you just pull your quill up, this will come down, and it will reverse the direction for you, and it will come out, and it's spring loaded, so as it comes out of the hole, it doesn't damage the first thread. And you can set right here with this clutch package, you can set that with a different tension on there, so that a smaller tap, you got less tension, a bigger tap, you use more tension. And we're going to demonstrate just how this works here in a minute. I have a block set up in the vise right now, and I'm just going to drill some holes in here for the tap size, and we'll show how that works. But before I do that, I wanted to show you one of the uses. We'll probably be making these in the future. There's different viewers that have been expressing an interest in buying these. They're not going to be cheap. They're going to be about $1,200. The steel alone is about $240 if it's made out of DC-53. And what you'll see though, on the front, the ones I make in the future, I will not have this hole because I do not use it. It's just going to be all tapped holes, because this hole right here, a lot of times when you're putting your clamps for clamping your parts up for grinding, a lot of times that hole does get in the way. So the future blocks, I will not have that hole there. But if I remember right, there's 100 quarter 20 tap holes here, and there's a number of them on this one side. And if I remember right, it was quite a few hours drilling and tapping them holes on a manual machine. A CNC machine, this would actually be pretty nice. And believe it or not, you can use that automatic tap head in a CNC machine. That'd be one of the projects that we use that tapping head for. And this sign bars that we're making 21 of them on our next run, and they have 1032 tap toes on there, and there's I think 7 of them in there. So this would be something, once I get the automatic tap head set up, and once the holes are in, I can just power tap all the way through those things and just slide it down by hand, and it will save us a lot of time on those as well. So anyhow, that's some of the uses that you'll have for it. Let's get started. I'm going to turn the 3-phase converter on. We'll drill our holes, and then we'll show you the function of that tapping head. When I drill holes, I don't like to center drill real deep. I like to just put a little spot. If you center drill too deep on that, what will happen is that that hole doesn't match the angle on your drill bits, and if you get a lot of holes, you start as you start cutting in, it will start hitting on the angle out here before the rest of the flute, and you'll get an uneven wear on your drill, and it will not last quite as long. So all you want is a nice little spot, and that just helps get the drill started straight so that it doesn't walk around on you. What I'm going to do, I'm going to set a stop because I'm going to purposely set this drill so that I don't go all the way through, because I want to hit the bottom of that hole to demonstrate that clutch ability. So that's as deep as I'm going to go right there. It's about maybe an inch, 3/4 to an inch, something like that. This is just a block of coal roll. The size of the drill I'm using is a number 5, which is 205. If you look on your drill charts for a 1/4 20 tap, they tell you use a number 7 drill, which is a 201. Most of the stuff that we do, we heat treat, and the holes will change on size, and we found out that if we use on-size taps, which I believe is an H3, what will happen is, and we use the 201, the number 7 drill, after heat treat, a lot of times our screws will not go into the hole. And so what we have done is go up to a few thousandths bigger drill, in this case about 4 thousandths, and then we go with an oversized tap, and we'll either use an H5 or an H7. And H3, I believe, is a standard, and each H number that you go, if I remember correctly, is like a half thou. So if you got an H5 tap, that should be about 1/1000th bigger than a regular size normal tap, the H3, and then the H7 is going to be about 2. And don't quote me on that, I'm just going back from memory. I do know that they're oversized. I think we even went so far in the past as using 5/1000ths oversized taps quite often. But most of the stuff that we do, we heat treat. And so instead of keeping a set of regular taps and on-size taps and a set of oversize, we just use oversize on everything, because at few thousandths most of the taps hold, it's hard to tell the difference. So that way, if you heat treat your stuff, you don't have to worry about the screw not fitting when it comes back. Be our last hole. We got 5 holes that we'll be tapping. Now if you go on Tapmatic's site, it's pretty interesting because they have some videos on there, and it's just unbelievable how fast they're tapping holes on a CNC machine with one of these. I didn't know you could tap holes that fast. So if you really want to see something that's kind of neat, check out their site. What I'm going to do right now, I'm going to chamfer the top of that so that we got a nice lead in for the tap. And I'm going to go ahead and use my stop to set that kind of uniform as well. I could really do that, just eyeball it, but a lot of times if you got a series of holes like that and you want to have a consistency, you can get the first hole set, get a nice chamfer on it, and if you got your stop set, all the holes will have that nice same uniform chamfer. And if you're doing your own work, maybe you might not want to spend 30 seconds I guess I spend on that. If you're doing work for a customer and you want that work to look really professional, I would encourage you to go ahead and set up a stop and get them things, the chamfers, to look uniform on all the holes, because you want to leave a good impression on people who are going to be buying your work. I'm going to lightly blow these holes out. Get some of the chips out. And I'm going to wind this off to the side and drop the table down. Go ahead and loosen the vise up. Clean all the chips out of here. Because what I'm going to do is I'm going to slide these down. We've been practicing earlier just to make sure that the unit would work. So the side there are tapped holes, but up on top the holes we just drilled, there's no threads in them yet. So I like to just put the part in there, get the jaws where they're a little bit snug, or not snug, but close, but yet where I can move the part. Now in order for this to work, you have a torque arm on here, and I don't have an instruction manual with this, but one of the things I did read online, you don't want to extend this real long. You don't want to grab and hold this with your hand. And what this does is it works in conjunction with the clutch to establish, I believe, the torque. They call it a torque arm. And what they want, this has to stop up against something. So I just made this up real quick out of a scrap piece of steel that we had. You can actually see one of the things that we did the paint marker in, solid rock. But they said that the arm, or the stop, that this hits against, you need to have that where it's stronger than whatever size tap that you're using in there. So we have a 3/8, 16 bolt that's going through there, and this is just something cheap and dirty I'm doing just to demonstrate this unit. We'll probably make something different in the future, but this will work for now. And what we can do, we can set our stop up. And I didn't drill that deep, and I might hit up here, but I think I'll be good. But I want to actually bottom this out so I can show you how nice this works. So I'm just going to get kind of close over there. This arm can go over here. As you can see, I can slide it up and down. That will work with it torque. I believe it said you can run this up to 1,500 RPMs, probably depending on what size tap. I would never recommend running a 1/2-inch tap at 1,500 RPMs, but we're going to put oil in each one of these holes. And I'm going to just hold this down with hand pressure. But right now I got this set. I got the tension backed way off so you can see what will happen. The way you set this is you want this to stop spinning before it breaks. And so you got to set that tension just right. So if you come over here, you can see it stops. So I need to set the tension higher. And but I want the tension to be so set where it will actually thread the hole, but yet when it hits the bottom, it will stop just like what you saw here. Right now I got the tension so light it won't even start the tapped hole. And so what I did, I just put a yellow marker that you probably can't see over here. So I'm going to just wind that down to about the place I've had that. And we'll start there. We should be good right there. And I may have to adjust it again because it's probably not exact. I forgot to put a cross mark on it. When I do actual work where I'm using this and I'm not demonstrating it, what I'm doing, and I want to slide something, I will have a system set up so that it'll keep this part from lifting. I might have it lift a little bit when I reverse the head, but I'm going to try to hold it down. Make sure that it moves. You see it stops, doesn't break the tap, just reverse the handle and up you go. And I could tell that it strained just a little bit going in and it slipped a little bit. So I'm gonna give that just a little bit more. You get the one hole done, you slide it down, let it center. There, 5 tap toes. Adam can probably come up over here and give you a close-up on there. And there you go. And that's how a tapping head works. And we'll probably modify things a little different in this for in the future, but that actually worked pretty good. Maybe I'll just continue to work on here. A lot of people always ask me on my vise, why do I have these button head screws? Well, you just saw one of the use right here. Sometimes I want to mount something on here that I can use, like in this case. I needed something that would stop this torque arm. And so I just took this block and I just drilled this hole so that I can put a 1/4 down in there, and it worked really nice. I used finger clamps. I made a set of finger clamps, if I can find them real quick. What I can use is I got these finger clamps set up that I've made. I had 4 of them. I only got a couple of them up there. But I can put a adjusting screw in here, you know, that I can raise whatever size part I got, and I can put a bolt at this point. And so if I got some real thin plate working here, and if you go to tighten that, if you didn't have these clamps, if you just wouldn't try to hold a thin plate and tried to clamp it, it will bow on you. So what I can do is I can take a pretty wide thin plate, I can pop it in there on some parallels, and what I can do is I just can come up and so that I'm about finger tight so that I don't get any side movement, and then I can clamp using these clamps over here on front and back and clamp right down on the parallels, and that is what actually will hold the part down, and then I can do my work. So anyways, modifying your vices and doing different things like this, that really comes in handy for some of your projects. Anyways, that's what this tapping head does. And again, it'll do from a number 6 up to a 1/2 inch. And the bigger the tap, the more tension you have to put on it. The smaller the tap, the less tension. And on the Tapmatic site, they're claiming that you're going to get a lot more life out of your tap. And as you can see, just putting them 5 holes in went real fast. So you can imagine when I got a cube and I got things set up so I can slide just up and down as I go, I don't have to worry about turning the machine off and on. It just stays in the forward, and this tapping head will just take over, pretty much like an automatic transmission for my tapping. Well, that'd be it for today. Hope you enjoyed. We'll see you next time.